Okay, this is our topology for today. So we have a one PC, which IP address is 192.168.1.120. Okay, for this, the
Okay.
gateway is firewall inside IP address, which is 192.168.1.2. And the second thing is like for this firewall, we have three interfaces. One is for management, which is 192.168.0.100, and second is inside IP address, which is 192.168.1.2, and outside is 192.168.1.10. And we have a router here, which is connected to the public internet, and the inside IP address for that router is 192.168.0.1. So any traffic coming to the firewall has a default one policy that inside to outside to permit anything. Okay. Apart that, just I want to know that you guys know about NAT concept.
Yes, I know a little bit about it. Yes.
Natting.
Can you please? I'm not much know about it. If
Okay.
you can mention here, it will be great.
Sure. I'll tell you about the NATing. So NATing is a network address translation, which is used to convert IP to IP address. Okay. If I have this IP address, which is my private IP address 192.168.0.1. This private IP address is local to only this much of domain, right? It can work only here. If this IP goes to internet, internet don't know about these private IPs. You know, guys, private IPs range, right? We have
Yes.
10 series, 172 series, and 192 series.
Yes.
Okay. So any private IP going to internet, it will won't come back because they internet don't have private IP routing. If anyone wants to go into network, they need a public IP address. Okay,
Yes.
public IP address is must. So to overcome this issue, we have a NAT. NAT in the sense I have a public IP address for consider like 3.3.3.3. So anything we have type of NATs there are dynamic NAT and static NAT. Static NAT is a one to one IP to one IP NATing. Static means one. If I have a 192.168.0.1 IP, then I have to NAT with one single IP, which is 3.3.3. Okay. For dynamic NATing, we can say that I have a whole network like 192.168.0.0/24. So I can map whole network to only one this particular IP address. That is called as many to one.
Minus to one.
Yeah. Always many to one is dynamic NATing and one to one is static NATing.
Okay.
And we have other called as PAT, port address translation. So if I have a 10 IPs, private IPs, okay, 10 private IPs, and I have a five group of public IP address. Okay, so I can do this also. This is also a dynamic NATing, right?
Okay.
And if I say I have a 200 private IPs and I have one public IP address. Okay, in this case we use a PAT, port address translation. So to any single IP, any single IP address, we have a 65,536 or 35 something ports are there, right? Do you know ports?
Yes, I know I know a little bit of port. So the
Ports like
port is yeah 443, port 20, 880, 80, port 80, whatever.
right, that is right. So these are all for any single IP. We have this much of ports. Okay,
So that is packed for any single IP. We have 65, six six
65,536
five five. Okay.
ports for any single IP. We have this much of ports. Nagraj, do you getting right? Hello, I think he's on mute. Okay, so if I have a 60,000 PCs in my network, I can use single IP address, single public IP address to connect to internet. So what happens if I want to connection with 192.168.1.20 with some google.com? So what it will do, it will take like 192.168.1.20 as a one IP, and it will convert to 3.3.3.3. It will pick up a randomly port something like 44444. Okay,
Yes.
so it will create one connection. Like that it will create like 5555. It will randomly pick ports and it will create a session. Okay.
Yes.
Okay, if I connect more than 6,536 sessions to internet, then this IP bandwidth will finish. Then we require another set of IP address.
Okay.
Okay, so if consider if I have only 700 PCs in my network, but from each PC, if I connect session about like 100, okay, the session count will go to 70,000, right?
Yes.
So 70,000 only for one IP, it is not possible. So require here two IPs, two public IPs. Did you got this?
Yeah. I think I. So now I'm gonna have 65,036 times two.
No, if I have a 700 machines in my network, and
Yes.
each machine is creating 100 sessions. If in machine I have a browser, right? In one browser I'll create a google.com, in another browser I'll create a yahoo.com, right?
Yes.
So each google.com is a one session and yahoo.com is another session, right?
Yes.
Like that, from 700 PCs, one PC is creating 100, then it will goes for 70,000 sessions. But I have only 65,000 ports, right, for one single IP. So
Okay.
for another 5,000 sessions, I need a different other ports, or we say other IP, which will start from again 0 to 65,536.
Okay.
So one IP, it's already totally consumed. If I have a second IP, then it will start again with 0 to 6,536. You're getting my point?
I got it.
Okay. So Nagraj, you are getting?
Yeah. Yes,
Okay,
I get it.
that's great. Okay, so I need public IP address as per your inside clients and session your clients are initiating. Okay.
Is there a way to limit the amount of connection that each of my clients are? Because I don't want each of my clients to have over 100 internet connections. Is there a way to limit how much each of them will have, how much connection each PC can have?
No, that is not there, but one thing we can do, uh, we can restrict the client to which site he has to allow and which site we has to
Okay,
allow.
okay, okay. That's how we, and that's when we come to URL filtering, right?
Yeah, that's right. If you want in detail for that, you have a separate called as proxy servers. Big companies, they maintain a separate proxy server.
Okay.
Okay, it is also a one of the sort of technology which has a deep knowledge we need for URI and the categories, everything. So I'll take a short note on this. I'll explain on this proxy. Okay,
Okay.
so you guys are clear in natting, right?
Yeah, I understand. I understand that. See.
In our case also, this is my private IP address. Okay, 192.168.1.20, which is goes to firewall, and from firewall you consider this outside as of now as a public IP address. Okay, 192.168.1.2 as my private. This is public domain and this is private domain.
Okay.
Okay, so 192.168.1.20, when it goes in public domain, this public domain don't know where 192.168 is there, so we have to NAT it here, NAT at firewall level with this outside IP address. Okay,
Yes.
192.168.0.110. Then only the packet goes outside. While returning, they know that 192.168.110 where it is, so it will return packet to this IP address, and it will again renat to this private IP address. Do you got it?
Yes.
Okay. So let me know whenever you are getting confused or anything you are not getting. Okay.
Okay, we'll do.
Okay, sure. So we'll do this practical now. So you got this topology and natting, and we'll it's already by default it's allowed, but we will restrict. We'll write manual policies here to restrict any traffic to outside. Okay.
Yes.
Okay, let's do that then. So I have a firewall. So if you want to check any traffic or anything, just show and question mark. You have all these uh, commands you can see here. According to you can check. Okay, do you want any commands list or something? I'll paste you. Few commands I'll share with you. But most of the things you have to do practice and you will get idea about this. So
Okay.
to check what are the IP addresses to interface I have configured, show interface, IP, and brief. This is command, so you can see that how many interfaces are there, what IP address is there for my to my interfaces, everything you can see as I diagram I showed you, like outside IP address is 192.168.0.110. Again you can see one more command like show name if. See, so how can you consider which one is which IP address? So 0/0 is my outside. Okay, you can see here IP address 0/0 is my this IP address. You have to compare like this. Okay.
Okay, so that's okay. Okay, I was wondering how you. I can tell by the IP address, but I can was wondering how you know which one is the outside and which one is the inside.
Yeah. So this show name if is the command. You can check which interface is what, outside or inside or DMZ, or according to what you have configured, that you can see here. Okay,
Okay.
these are the zones: inside zone, outside zone. Okay.
Okay.
Okay, if you want to check what is access list that is configured, you can see here show access list. Okay,
Oh,
it's showing somewhat in detail here, but you can execute command show running access list. So you'll get detail. Sorry, actually, this is your access group. NGFW onbox ACL is an access group. Okay, remark is something like we give as a description. Okay, so
okay.
access list. This is the actual access list. You can see like access list NGFW onbox ACL advanced permit IP ingress interface is inside object it inside PC. I'll show this in GUI because if you see in CLI you'll get confused here. Show everything in GUI. Okay, so this is
Okay.
for your knowledge how you can see the access list in uh, CLI. If you want to check can I show natting, so you use show nat command. Here you can see the natting from CLI, or you want to see the actual stations in nat, you can use show escalate. So these are the entries in the
The NAT table.
table. That's right. If you see that NAT TCP PAT, okay, from any 192.168.1.20, which is our inside IP, which is going to 192.168.0.110, which is my outside interface on this particular uh, IP with particular ports. We are using PAT as of now because we have only one public IP address, which is my outside interface.
Okay.
Okay. Actually, this is an VMware setup, so we can't use other IPs. I'll show you in other cases, like when we go to FMC, I'll show you with that because this is not supporting with other IPs. I have checked yesterday; it is not supporting. So I'll show on different in FMC with FMC it will support, I think. So I'll show in on that how to do natting on each and every scenario or use cases. I'll show in that. But as of now, you can consider that we are having 192.168.1.20, which is my inside. So it is natting to 192.168.0.110, which is my outside interface IP address, right?
Okay. Yes.
Okay. Here you can see that my inside IP address, it's getting lost. I want to disable the logs. Let's see. So these are all the sessions which is creating from my inside PC. Okay, here it will
Okay.
taking I think some update from the public IP address. Okay, so I'll show you each and everything how you can see the logs from CLI, how you can see the everything from CLI as well as the GUI. So okay, we'll move to GUI now. So as we saw yesterday that we can configure interfaces, we can configure routing, we can take updates and everything from here. Okay, we can do everything from in device related configuration in device tab. Okay, so you want to change management IP address, so you just go to here management interface and you can see this is our management IP address. I have taken the session with this IP address only. You can change from here, but for temporary basis you will go the access once you commit or deploy the policy. So you can change anything. You can do if you have any external syslog server, so you can add here. Okay, do you want to configure any DHCP, you can configure from here. So while configuration we have used the default DNS server, so which is Cisco umbrella. So here we have the configuration. If you want to add, so we can add here as well. Okay, so if you want to change the host name for this, you can change from here. Okay, these are all the system device related configuration which we can do in this tab, in device tab. Okay, now if you want to see the logs or device health, so you can just come to monitor in system. You can see the dashboard shows the everything related to device health and all the events and any your so which we are running software version, everything. Okay, if you see, this is my Cisco Fire FTD VMware, and I'm using a version of 6.3. Okay, and what is my management IP address, and here which faces are up, you can see as a green. If anything is goes wrong, it will show in a red color.
Okay.
Okay, so if any issues encountered on the interfaces, it will show in a red, then you have to do troubleshoot according to that. Okay, so average throughput as of now it is nothing because we don't have any traffic, so we'll check it out later. So you can see.
I have one quick question. So for this one here, we have 8 interfaces. So normal firewalls, you have inside, outside. Why would we need that many interfaces?
Okay, let me tell you. Interfaces, sometimes what happens, I need one for inside, one for outside. Someone they have DMZ, so they'll use for that. Okay,
Okay, okay, okay, okay.
and someone what do, this is my only 1 gig of interfaces, right?
Yes.
What I'll do, I'll combine these two interfaces and create one logical interface to increase my bandwidth.
Okay, okay, I could do that, right?
Yeah, we can do that. But as of now,
Okay.
this is our lab environment I'm doing in
This
VMware. We
is
can't do, if in real scenarios we can do it.
okay. I
we,
understand.
we can combine these two interfaces and we call as an bond or port channel or port bundle. We can bundle these ports and we'll create one logical interface, and we have the bandwidth of twice. If it is 1 gig and 1 gig, my total bandwidth is 2 gig.
Okay, and that's for sometimes if I have an internet pipe, a 2 gig internet pipe or a 3 gig internet pipe. That's how I would do it, right?
Yeah, that we can do it from here. If my traffic is choking here on interface level, so we can do it and everything here. So we can use multiple interfaces, or it depends upon again on company to company, because if you order with 40 gig also, this interface will receive a 40 gig SFPs and we have to insert it, and we can work with 40 gig also as a single interface.
Okay.
It totally depends while you are ordering the devices, because sales guys and your architect will suggest devices how they want, because they analyze existing traffic. On that basis they give the recommendation and they place the orders of devices.
Okay.
Okay, so this is average throughput. If this is like consuming more and more up to 16 bps, then we can say that this firewall is overutilizing and we can have higher hardware, something like that.
Okay.
Sorry. Okay, so these are events in the sense our logs, how many sessions are there, everything. And this is CPU utilization. So as of now my firewall is using only 15%, and this is the memory utilization, everything we can see here. Okay, and this is network overview. So you can see more while we going further. As of now I am explaining only firewall. Okay, so we'll do today like firewall and HA, and after that we'll go step by step with application and URL filtering, URL, what are the URL categories, and all these related what we say traffic logs we can see here. If anything related to application we can see here. So as of now my PC is going for, I said like it is going to update, right? So you can see that my PC transaction are 2. Here it is going to Microsoft. It will log each and every packet and analyze it, and it will show in logs here.
Okay.
Okay, what are the URL categories, what my traffic is going, all this. Zones, like I can say that my inside to outside, as of now 20 transaction is happened. Transaction is in the sense the sessions are happened. You can see how many transactions are denied, because my rule is allow everything, it is not denied. So you can see that how many total transactions are allowed and total transactions are denied, and what is my total MBs of download, transfer bit. So you can see everything here. Okay,
Okay.
and for which destination my packets are went. This is for DNS, and this is for I think Microsoft IP addresses. Okay, as of now it is only one single IP address, so you can see minimum transactions and minimum IP address. But when it's in big network, you can see huge amount of IP addresses, huge amount of transactions and everything. So mostly we won't go all these things, but when sometimes if my particular it is not particular website is not working, my IP for that IP address, what is the for particular website, what is IP address, and is there any previous transaction or not, we can see here, and we can do troubleshoot, or we can analyze like what is that, how many transaction, who are the users going to that. You can see here who are the users in the sense which is my internal IP address. This guy is going to this particular IP address. So we can analyze more on IP addresses if we have multiple IP address in inside. Okay. So just as of now, I'll show. So more we see logs is here in events. This connection is our real-time connections. If you see, this connection is real-time connections. Okay.
Okay.
And
I got that.
all events you can see here, which one is allowed, which one is not. If you want to add or remove, this is limited options you can see, but if you want to add more options here, so just click on add or remove columns. You can also include here like what is my ingress interface, egress zone, and IP address. Everything you can do from here. Initiate IP address, responder IP address, client IP address, and which policy it is using, what is the country it is going to. Last, anything you can just add here and click on OK. You can see here, right?
Okay.
So if anything want to see in depth, you can just go to here and you can check here. Okay. So as of now, I'll show you. Just a second. Where is my PC? So this is monitoring. So this is object group. Object. Okay. Object tab. If I have an inside IP address, I want a policy that this is my inside IP address, and I want to go to Google, internet or somewhere. I want to write a policy. Before writing policy, we have to create um, this
An
object.
object group.
Yes, object.
Yeah.
So I create here objects. Like as of now, I think I have created. I'll delete it, and once again we'll create. Okay, I'll delete everything as of now. Okay, it is not getting deleted because it has
Oh,
policy.
because it's been used right now, right?
Yes, that's right. I was doing yesterday some R&D.
Oh.
Okay, so let me delete one second. I think I have written a policy, and I'll delete this policy. So these are the changes we have did as of now. We have removed the inside network object and host. Okay, and we have one policy, right? Yeah, this is the policy we have removed. Access role removed, which is my policy name. You can see everything here. As of now, I'm deploying these changes. What you have removed, it shows in red color, and if you add something, it shows in green color. Let me show. As of now, we are deleting everything. You can see in red color, right?
Yes.
So I'll deploy this and just wait to deploy this policy or changes. If you're not getting anything, just stop me and we'll discuss on that.
Okay, that sounds good.
It's showing fail for me. Why? If it is showing fail and we can see here deployment fail for an unknown reason, please try deploy changes again. If the problem persists, reboot the device. If you continue to have problem, contact technical support. Okay, we'll try once again for deployment. Like this, you can see what is the reason for any failure. Okay, if
Okay.
you just go to audit logs, you can check why it is failed, what are the tasks. You can see the detail error, and you can capture that error and Google it for if you want to troubleshoot on that. Okay, this time also it's failed. It should not fail because we are not doing any other tasks. It's still failing. Let me check once again if anything I'm doing wrong.
I got it so far.
Okay, so to avoid failure at any point, we have a second device, and from if the traffic flowing through that device the device fails, the traffic should be diverted to the second device, and there is no time at any time. So this is called an HA. For this HA, we have two types of HA. One is stateless and second is stateful. I'll tell you what is stateless and what is stateful. Okay. Suppose I have a two firewalls. To know each other health, we have a link called as an failover link. FO link. Okay,
Okay.
this is failover link. Let's suppose I have a outside interface here, or we can connect here a one switch. I have one switch in inside. This is inside. This is outside. Okay,
Okay.
and this is my primary. This is my secondary. Okay, so we have two types of HA. One is active standby, and second is active active. Okay, mostly preferred active standby only. Very less. I have seen very less active. Okay, for active standby, this one is primary, this one is secondary, but this one is active and this one is standby.
Okay.
So any one device we can consider as primary and one as secondary, but anything can be active and anything can be standby. So FO link is used to check health status. So they will ping each other and exchange a health status between these two devices. If it will ask like, hey, your health is how like your interface is outside and inside interface and CPU utilization, your memory is everything is okay or anything is uh, goes wrong, please let me know. So I will be convert my standby to active, something like that. So these call are the keep alive, keep our heartbeat messages will flow between these two firewalls, and according to that they will maintain their health status. So for this it will use a FO link. Okay, so let's suppose like if this interface is gone, so it will tell us like my inside interface gone, you can take over, then it will convert this standby to active, and it will convert by active to standby. So this interface gone, so all traffic flowing from here, it will goes from here. Okay, any issues?
No, we're good.
Okay, so we have one more link. Okay, for this they called as state link. Okay, state link in the sense, as you guys know, we have a stateful table, right?
Yes.
We maintain a state table.
Yes. Yeah. Yeah. Well, it's the state table with each connection and its information.
Right. Suppose consider like if I don't have this link, only here, let me tell you, I have one PC, created a station. Okay, and here in state table I have a like this inside PC goes to google.com. This station is there. Okay, these has initiated a station, but this station is not completed. In between, this link has gone down. Okay, so all traffic will flow from here, right?
Yes.
Yes. In that case, what happens? This state table is maintained in this firewall. So the session initiated, it will break down. So if you have to create one more session from this PC to again to google.com, right? To avoid these type of scenarios, we have a separate link called as an state link. What this link, what it will do, it will copy the state table entries from active to standby. Whatever entries are there in state table, it will copy from active to standby. Means both devices state table will get maintained. So if any point of failure, the traffic will this device will not need to create a new session to Google. The whatever state or previously was there, it will there in this device also. The session reverse packet comes and it will checks the state table and it will allow to inside PC. Did you got?
I got it.
Okay, Nagaraj. Hello, Nagaraj. I think he is busy somewhere. Okay, so to replicate the state table, we have a separate link called a state link. So whatever state table entries are there, it will get copy from active device to standby device. So
I have a quick question, sir. So if I have for HA, I need two physical link between the two firewalls, a failover link and a state link.
yes, this is recommended. This is a standard practice. Okay. Again,
Oh,
to do an HA, there are prerequisites like same hardware model, same
and
software
version
version.
and version everything. Yeah.
Yeah, they are same type of memory, same type of license.
Yeah, they like them to be vertically alike, virtually alike, everything, same model, same software, same amount of RAM, same version, and everything.
Yeah, everything they require same. Then only we go for HA. Once we go for HA, we have to think like if you want stateful HA, then just create two links. Or this link also we can create as a state link also, but we have hundreds, thousands, lakhs of transactions, right? Lakhs of sessions. So everything from this interface, it will get its overhead, this link. And maybe it will make a mistake to analyze the state of the health of these devices. So due to that, we Cisco recommend you have to create a separate link to exchange the status. Good.
Okay, I got it.
Okay. So if you have any question, just let me know. So we'll discuss on that again.
No, I'm good.
Okay. So for active, as we studied, like this is active and this is standby. In that case, like they have active device here and active device here. Some traffic will flow from here and some will go from here. Both devices are active at a time, and both devices will exchange their health as well as their state link, stateful tables also. Okay, through state link. This is our HA concept. So let me check to on this device once again.
What are the prerequisite for stateful and stateless to farming?
Uh, See, for HA, it is already defined that we need same type of hardware, same type of version, same type of license. These are the mandatory things for any HA. If you want to do stateless HA, so we don't require to configure state link. Only failover link. Only one link is required. Okay. And if you want to do the stateful, then just Cisco recommends one separate interface, but you can use this interface as state failover as well as the state link also if you don't have the extra interface on your firewall. In that case, you can use the same interface for both for both the functions like failover as well as the state. Okay, but it is recommended to use separate interfaces for failover and for state link. So this is the recommended. So do you have any questions, Nagraj, again?
No, I if I do practical, I may be able to get some idea.
Yeah, yes, definitely will do that. Just give me some time. It's getting booted. Yes, configuration is very similar to the ASA when we see only for seeing, because we can't do anything from CLI. Everything is from GUI.
Okay, I did not know that.
Yes. If you see
There's
like,
no there's no configuration. So the only configuration they allow is when you put in like the original IP address and the name, just so you can log into it. But all the other configurations gotta be done from the CLI, right?
yes, if you see like here, everything we can see same as an ASA only. All configuration is same as an ASA, right?
Okay, okay,
Everything is ASA here. If you consider for firewall, if any packet going beyond the firewall, consider as URL filtering or something else, it will go. I'll show some one diagram so you'll get clear, I think.
okay.
So how they are designed for packet processing is like let me tell you, if this is an interface, if any packet is coming to an interface, okay, first it will, they have two engines, Lena and Snort. Okay, Lena is Cisco,
Okay.
Cisco ASA, and Snort is SourceFire. Okay, do you got? They have mixed both this engine and they have created firepower.
So the one FTD has two engines.
Yes, first is Lena and second is Snort. Anything related to firewall, like a layer 4 decision, it will done on Lena engine. Anything,
Anything related to firewall is done on Lena engine.
yeah, anything that beyond the layer 4 engine, it will goes to Snort. Layer 7 related inspection or anything, that it will goes to Snort. Okay, if you enable IPS, if you enable URL filtering or AMP or network, they have I think network analysis. So for that, it will goes to from the when packet is ingress, it will goes to Lena engine. Once the Lena engine is processed, if we have enabled all these features like IPS, URL filtering, anything, it will forward packet to Snort, and Snort will check everything, and it will give a verdict, or like we can say allow or block or trust or something like that. So according to that, again it will send to Lena. According to this verdict, it will allow or it will block.
Okay.
Did you got right?
Say that one more time. I didn't quite understand the last part. So
Okay.
you say smart and Lena work in comparison. I didn't quite understand that.
Okay. So previously Cisco SA is running only Lena engine.
Okay.
Okay. So in ASA, what happens? It will only check up till layer 4. Like this is IP address, this is my port source, and this is my destination IP address, this is my destination port. So if these things I want to allow, so then it's allow. But it will want to go beyond layer 4 inspection. something like that. IPS is like signature base to I'll tell you on IPS or anything, URL filtering or AMP, right? These are all are layer 7 inspection, right?
Yeah.
If I have enabled any one of these inspection, the packet should go from Lena to Snort, because these features are inspected by Snort engine.
Okay, I see what you're saying. If it's anything beyond layer four, then it's being related. It's referred to the Snort engine because that has a capability of doing anything above layer four, right?
Yeah,
The
that's
new
right.
the next generation firewall capability.
Yeah, that's right. You got that. So once the packet comes, it will go to Lena and it will check like if so this is source IP, my this is destination IP, and this is my port ID. If it is allowed, then it is okay. Then if I have configured anything related to layer 7 inspection in that policy, then it will for packet that packet is forward to Snort engine. Then engine will analyze and it will gives its verdict, and it will send against to Lena engine. Whatever the verdict it was sent, that is analyzed, and according to that the packet is allowed or the packet is denied. If say I have A is my source and B is my destination, and it is allowed, okay, this is my policy. And also in this policy I have enabled and layer 7 IPS inspection, okay.
Okay.
IPS inspection I have enabled. So once the packet is A is came to my firewall, to my Lena engine, here I can see that it is allowed. It is allowed, okay. Then it will check IPS is enabled. So the Lena, what it will do, it will forward to Snort engine, okay. And it will check. After checking, it analyze that there is something malicious. It is some sort of brute force attack, okay. It is happening a brute force attack, and in my IPS engine I have told that if anything is brute force attack, just drop the packet, okay. But in my firewall it is allowed, but in not it is telling drop packet. So this verdict again it will send to Lena engine, with saying that drop the packet. If firewall is allowing, still my IPS is dropping. So what it will do, it will take a decision to drop the packet, and it will gives and log that to why it is dropped. You got right?
Okay. Yes.
Okay. So if you have any issues, let me know. Like if you didn't got anything.
Does it create an event?
Yes, yes, it's
Uh,
great. This log is called as an also event.
oh, so the log is okay. Log slash event. All right.
It will create an event, and we can see why firewall is allowed, but in IPS we got that brute force attack, which is a known attack. In IPS we have told that to if it is brute force attack to drop it. So you will get everything in log event,
Okay.
and you can analyze that in that on that basis. If it is brute force also, I want to allow this packet, then just go to IPS and say that if it is brute force also, from don't drop it, just allow the packet, then the packet will
Okay.
allow.
Okay.
Okay, you got like what is Lena and what is not.
Yes, I understand that.
Okay, uh, just we'll take a 5 minutes break. Okay, it's 9:05 at me, so we'll take a 5 minutes break, like 1 or 2 minutes break.
Okay, that sounds good.
Yeah, just give me 5 minutes, I'll come back.
Okay.
So this is our evaluation license. It will create this. Okay. This I'm agreeing for the evaluation license. I'm giving the new password. IPv4, yes, I am going to configure. No, I don't want IPv6. I'm going to manual, and my IP address is 192.168.0.100, which is my management IP address. Subnet
That's
is
your, okay. That's your management, right?
yeah.
Subnet is a /20.
/24 is subnet, and I am using my gateway, which is 0.1. Okay, so
Okay.
my host name, I'm giving the default host name, which is firepower, and after the DNS is 8.8.8.8.
That's a public DNS, right?
Yes, this is a public DNS, right? Service domain or none. If your networking information has changed, you will need to reconnect. Okay, as we are in console, that is okay for us. Manage this device locally. Yes, we are managing this device locally.
Okay. That's because we're not using FMC, right?
Yeah, that's right. So we'll spin up tomorrow or day after day. We'll do with the FMC. I
Yeah.
think what we'll do instead of 8, we'll do from 7. Is that okay for you?
Tomorrow? Yes.
No, day after day. Tomorrow you are taking a holiday, right? So we'll take a leave, one day off.
Okay, so we'll take a 1 day off tomorrow, and Friday we'll start. The next day we'll start 1 day. We start 1 hour early.
Yeah, that's right. Because what happens is if we get these type of issues, so we can cover it up the time.
Okay, that sounds good.
Yeah, I'll power up these things as of now for, and I'll connect my interfaces. So last time when we are configuring these interfaces, it will got hang, right? I don't want to do that again.
Okay, so what you do? You took you that part. What that part where you say do that one? What are you doing right here? I don't quite understand that piece.
Okay,
What
let me
the
tell you
or in
that.
yeah.
Okay, I'll start recording also. Recording. Okay, we started recording also. Let's check
Okay.
it out. We got GUI or not. Let's check it out. Okay, so we got GUI here. This is fresh one. So still we have to wait for a few minutes. So the one minus point in Cisco nowadays is only this GUI. Previously, ASA was very easy, straightforward. We can do anything from CLI. Any configuration changes, anything we can directly do from CLI. But in new, it's getting very mess.
They don't do a lot of they're removing some of the CLI functions, eh?
Yes, we are very much addicted to CLI previously. Now we have to do mostly on GUI only. If anything comes for troubleshoot only, then we have to move for a CLI. Apart else, everything is working from GUI.
Okay.
Check it out. Let me ping. It's pinging.
Okay, so it's up.
Take some time.
Cool.
It will take some time to load the GUI. So we have to do pay with patience.
I can see.
Yes. Yes, we can see.
This is my outside interface 110 and
Yes,
cable.
I can see the screen.
Okay. So our device came up and we are configuring initial steps.
Okay.
Taking. Okay, so our time is Asia. Okay, so I'm changing the inside interface. I'm deleting the DHCP
Okay.
and I'm giving here .1.2
By
starting.
default, by default, it come up with DHCP, right?
Yeah, DHCP and 45.1. So I'm changing to 1.2, which is my inside interface. So this is my outside
Okay.
interface. So I'm deploying the changes.
All right.